Over the next couple of weeks, we are going to be getting into a brand new topic dealing with angles. Now, I know in the past you guys have been using angles all the way back in 4th grade, and you even did some of you did a little bit last year on angles, so some of this will not be new to you. However, I wanted to start off with everyone at the same page here, so I'm going to start with an introduction on angles. So first of all, what are angles? Now, I looked this up on the Google, and if you look up what is an angle, it will tell you this exact definition right here. An angle can be defined as the figure formed by two rays meeting at a common endpoint. Angles are measured in degrees using a protractor. So before we begin, because they have some words in here, I want to make sure we understand. A ray is not, well, let's start with this one. This is a line segment. A line segment has two endpoints. You won't always see them, but it has a spot that ends right there and right there. Sometimes you will see them written like that. We have a second one known as a line. Line has two arrows on the end of it. What this means is that this line goes on forever and ever and ever, and it will never stop in either direction. Okay. Now this line is still straight. It is not a squiggly line as you may think of a line. This is a perfectly straight line going in two completely opposite directions. And we also have a ray. The difference between a ray and a line has one endpoint, and the other side goes on forever and ever and ever. Now, what we're going to be discussing today are angles. And angles are looking at, it could be actually formed by any one of those three. The most common ones that you are going to see that are ones made up of two rays that will meet at a certain point right there. And this distance, we don't really call it the distance, the measure of how, I can't really use the word angle here, the measure of the space in between them at the angles they are going at is our angle right there. We measure with degrees. With degrees, not degrees Fahrenheit or Celsius, just degrees, and we use a protractor. So if I bring up my protractor, if it will let me bring my protractor, give me 1 second here. Here it is. So let me just bring it down here, show you guys how to measure an angle. So I know you guys have dealt with this last year, dealing with angles, but just to show you guys this right here. So if I want to measure this angle that I have drawn here, I'm going to put my protractor on the dot, on what's called the vertex. You've seen that word before when we talked about shapes, but it is where those two meet, where those two lines, or in this case rays, are going to meet one another. Now I want to adjust this, so I can turn this protractor, and I want to make sure I turn it so it's on. Now the problem is on this line, I'd be measuring the outside of this, which I don't really want to do. I want to measure the inside. So when I turn, let me measure what's going on inside here. Okay. Now the protractor I have here, I can make it larger or smaller. I'm going to leave it this same size right here. I could make it larger or smaller just to show you guys this. But I need to look at which of these numbers I'm talking about. Now, I'm going to go over them in a little bit about acute and obtuse angles. But just to show you this right here, this one is an acute angle, which means I'm going to use the smaller numbers right here. So this one right here is between 40 and 50 degrees. I'd say it's probably about, oh my goodness, my eyesight's getting worse and worse, about 47 degrees. This angle here, 47 degrees. Now let's give us another look, and let's actually talk about different types of angles. So the most common one that you guys are probably familiar with is known as a right angle. Okay, a right angle looks like this. It has a line that is straight up and down. Let me actually undo that one. Straight up and down. And it also goes straight straight to right. Now we call this a right angle because it is 90 degrees. And we offer a box instead of a little line to show that this is a right angle measuring 90 degrees. Now this right angle could look like this. We could draw it like this. I'm just fix that. It looks pretty good. Right angle. Whenever they have a right angle, you will almost always see the little box there to tell you that it's a right angle. This is not a left angle because it's going to the left side. It is still a right 90-degree angle. And same thing, what if we had one that looked like this? It does as I can here. I think that looks pretty good. This is still a 90-degree angle. It's clearly been turned. Please don't check me on this. I'm just drawing freehand right now, but that's about 90 degrees. Sometimes you will see things like not drawn to scale. That's what I just did right there. That is not drawn to scale, but that is supposed to be another 90-degree angle you can measure with here. This is something that is smaller than 90 degrees, so I always like to use the example of things that are little are cute. So we have an angle right there. That is an example of an acute angle. This one right here, I could measure it. It would be somewhere between, I guess, to 90, not either one of those. We cannot have an angle 0 degrees. That would be the same line. We'll get to that in a second. And we have 90 degrees, which of course would be a right angle. So this would be anything from 89.99999 all the way to 0.00001 degrees right there. We have an obtuse angle. Obtuse angle, this is one you probably learned as well. An obtuse angle has, let's just draw a terrible looking angle there. Sorry, my drawing is getting worse and worse. This one here, the measurement of this angle is greater than 90 degrees, is probably what you have learned. That is not exactly true. This one is between 90 and 80. These are probably the most important numbers we are going to use when we are talking about angles. A lot of things talking about angles, to use those numbers, we're going to keep referring to them 90 and 180. So anything that is 107 degrees, anything that is 94 degrees, or anything that is 172 degrees are all obtuse angles. Now we have two more types of angles here. We have a straight angle, and I'm going to draw this out, and you guys are probably going to be like, that doesn't even look like an angle. And you may say, oh, wait a minute, that looks like a line, or actually line segment, or a line, but it is in fact a straight angle. These two angles meet, and I put my X right there. This angle and that angle are going in completely opposite directions. Okay, this is like a 90-degree angle with another 90-degree angle. So it is 180 degrees. This entire thing from here to there, 180 degrees, and that's kind of why a circle, whether you knew this or not, is of 280 degrees, so 360 degrees. That's where that comes. And the last one, you're probably not going to use this at all this year, but I just wanted to show you what this looks like. So a reflex angle looks like this. And you're saying to me, well, Mr. Kowalski, doesn't that look like an acute angle? That would be true, except the reflex angle right here, a measurement that is actually greater than 180 degrees. So this is anywhere from between 180 degrees and 360 degrees. This is a reflex angle. Okay, so let's start talking about a little bit more about angles here. So let's talk about naming angles, okay? Now, I can't just say, this angle's name is Bob or Jim or Emily or something like that. We're going to actually name these angles based on the numbers we see associated with them, okay? Now, the first thing I want to tell you about these letters here is they are capital letters. And when we are labeling angles, we are almost always going to use our capital letters here. Now, we use capital letters, and usually you don't use capital letters in math. You use lowercase letters because lowercase letters stand for variables. These are not variables. These are actually points on each of our lines. So let's say, for example, let's scroll down here for a second. Let's say I wanted to label a line. This line has 2 endpoints. I'm going to label these endpoints with little dots there. I'm also going to label them with letters. So maybe this is A, B. Makes sense so far? Okay. Now what if I have a second line? We'll call this line, I don't know, let's draw it right here. Line now. I mean, it also shares that same endpoint of A. Let's draw the other one right here. We're going to call this one C. This angle that we have here, which is treated, is made up of line segments AB and AC. And when I want to label this angle we have here, I need to start at one of the lines, go towards the vertex, and then use the other line. So I'm just going to trace this right here. I'll erase it in a second. But if I wanted to name this angle, I would start at C, A, and I would call it angle. That's the symbol for angle. It's not an L, it's an angle symbol. C, A, B. Now you may be saying, well, wait a minute, what if I started at the other line? Here we go. Starting from towards A, going to C. Angle B, A, C. Both of those are labeling the exact same angle right here. They are both correct answers for what angle this is. Now sometimes you may see a little bit letter here, A, that also, this is angle A. Okay, but more often than not, we're going to be labeling them with the actual letters that we see here, BAC, CAB, just so we make sure we're not talking about things like C to D. It would be this angle right there. We don't want to use that angle right there, and that's kind of an example. Sometimes we will see things like lines crossing. Maybe we have 2 lines crossing like this, and we have a bunch of different letters here. So we have things, I don't know, let's just do math right here. M, A, T, H, my, we'll call that I. Sure. Okay. And from this, I can name a ton of different angles, depending on where I want to start with. So maybe this angle right here, what is this angle called? Well, it is M to IA. So that's angle MIA. Or we have angle IM. The important one, obviously, is that these outside letters right here could be swapped. That's one of the things to look at here. Okay, and maybe just one more looking at this example I have here. Maybe this one is angle H I angle M. Okay, in any angle they actually tried to label on this drawing I have here, the I is going to be in the middle because the I represents the vertex. So if I want to talk about this one I already have labeled here, what is angle? What angle is that? Well, I'd have to start with what the 2 points are on the lines. So you might have seen them there. A and C, P make up that angle. And it doesn't matter where I start. I might go to P. So angle P, angle C, P. That way I have to say, oh, it's on the left. Because which angle on the left are we there? We don't really know. Or I don't need to say angle P, because angle P has all these different angles for angle P. I don't want us to get confused on which one we're talking about especially if I try to say, what is the measure of this angle? This way we understand. So let's take, oh, I think we already did that. I shouldn't have done that there. Let's take a look at one more. This is an example we're actually going to try next week. Okay, it's made up of a bunch of different lines here. Well, actually, it's made up of two lines. It's made up of line JL right there, JL, and it's made up of line KM, but it's also made up of a ray, made up of ray EN. And we call that ray EN, as a ray. It starts at E where there's a point, and it goes to N where there's an arrow. Okay, but we'll get into that a little bit more as well. Now, if I want to label any of these angles here, I might look at them and say, you know what, maybe to solve this problem, we may need to look at the angle on the right first. Well, that would be this angle right here. This is angle MEL or angle L. Okay, both of those represent that angle right there. Now, obviously, if I were to be solving this problem, you guys would probably say, well, wait a minute, though. The x is what I really care about, the variable. We see that right here. What angle am I actually trying to solve in this problem? The angle I'm actually trying to solve is the one that goes from J, E, N, which in that case is labeled as 3x. Call that angle J, N, or angle N. Either one of those we could use. That way we know what angle we are talking about. Okay. Expect to see some questions on that today. Now, the last thing I want to get to are two more types of angles. We're going to talk about a lot of different angles through the course of this, the next couple weeks here, but I wanted to take a look at two more. And these last two are called complementary angles. Okay, sorry guys, complementary and supplementary angles. So the first thing is complementary angles. The thing about them is they are two angles I told you 90 degrees is going to be a very important one here because 90 degrees is a right angle. We took that right angle and we broke it apart. Look at that, split it. It's made up of now this angle of the red and this one, which so now I cannot say, oh, look at those two angles there. Well, it's 90 split up. I bet they're both 45. We don't know that. It kind of might look like it, but I might say this one is 50 or 55 here. We're going to say that. This is 55 degrees right here. What does this angle have to equal to? Well, very simply, 55 equals 90. No way! Set up. Before we really need to there. 5 degrees. Answer. Any questions? No questions? Awesome. So let's continue on to, I guess we can do one more on complementary. That's basically it. Once you know what one of the angles is, you can always subtract it from 90 to solve the other one. Remember, not always going to be perfectly like this. As long as you see that 90 degree that you have right here, that little box, it means that it's 90-degree angle. Okay, use that to help. Last two numbers right here. Complementary added up to 90. Supplementary add to 38 degrees. We said that was a line. So let's take a look at this line here. Here's my line. Right there, line. Now this line is going to be broken apart. And I'm going to draw a little ray. It doesn't matter from where. No, that 180 is split. Man, if it was split into, no, I didn't mean to do that. If it's split into equally in half, it would be 90 degrees and 90 degrees, but this one is not. So I can use this to try to solve my problem. So I could say, hey, maybe this angle right here is 70 degrees. What is angle here? Again, I don't have to use x. I can any variable I want. I could even label it with the points we have here. Angle D right there. Or I guess angle dab, but I mean, this isn't like 2015 here. But we have this angle x right there. I could solve it. 70 plus 80 or 180 as 110. Not too bad. Now be aware. You may see angles that look like this. We try here. Here we go. We have that one there. Oh, you're saying, hey, Mr. Kowalski, this isn't too bad. I understand this. I don't have any problems with this at all. But what if we have something that looks like this? X degrees and in parentheses 4x degrees. What? This is way too tough. I don't know how to solve this. There's no numbers right there. Well, I guess what we can do is we can take these and say, well, I have to add up 180. What if I took this and solved it? What is x and 4x? Oh, it's 5x degrees. Divide by both sides. And all beforehand. What is that? That's 3 and 6. 36. I hope that's right. If it's not right, please leave it in the comments that it's wrong. 36 degrees right here. And I didn't solve this beforehand, so we're going to try this out. That means the other angle is 4 times x. 6 is 4. That's 4. 14. 104. 4? That looks right. Final check. Oh. 36 and 80 degrees. And there we go. We are going to get more into this next week. It's going to get a little bit more complicated. Please try the problem we have today. And I will go over this if we need to during our math session. Any questions you may have. And I'll try something a little bit more difficult on Wednesday. We'll see how that goes. All right. See you guys.